Ready? Hello, my name is Brad-Schick. I'm the CTO of SkyTap, and I'm here to talk about why most enterprise applications will evolve to the cloud. This is what we're going to do today. First, I'm going to do some slideware and talk about hybrid applications, which is a mechanism for enterprise applications to start adopting the cloud. I'm going to do a quick demo of SkyTap, and then we're going to bring up some SkyTap customers and do a brief panel and ask them about some of their cloud adoption. And then if there's time at the end, we'll do a brief Q&A. So if you have any questions, please hold them to the end for the Q&A. While cloud computing offers tremendous opportunities to improve the efficiency and scalability of enterprise apps, cloud adoption within the enterprise has really just begun. This is a quote from Gartner that talks about the increased speed of adoption and how 2014 is likely to be a turning point in the adoption of the cloud within enterprises. There are still a variety of obstacles, however. One of the key obstacles is the way that people think about and plan for cloud adoption. The focus tends to be on either greenfield applications that are being created from scratch or the creation of hybrid infrastructure. Greenfield applications are often designed from inception to run in the cloud. And while those do appear in the enterprise from time to time, they certainly aren't what's running the core of most businesses. So that design pattern for applications isn't really always applicable when thinking about how to adopt the cloud in the enterprise. Hybrid infrastructure, sometimes called hybrid clouds, the focus of that is about how to combine on-premise infrastructure with cloud infrastructure. And while hybrid infrastructure is very useful, it doesn't solve the really hard core problems of how to uplift your applications that run on that infrastructure. So while it's useful, it's not often sufficient as a mechanism for starting to adopt the cloud. So when considering complex existing enterprise applications, what's really needed is a deeper focus on the applications themselves. How can the applications be extended to take advantage of the cloud? So in this graphic, I show just one service being optimized and migrated out to the cloud to take advantage of cloud resources. This is what I'm calling a hybrid application. And the idea is that it's an existing application that's had just one of its components moved or optimized as a place to get started. So before I get into more details about hybrid applications and what that means, I'm going to go over a few reasons why I think this is a pretty likely path for adoption of the cloud within enterprises. So the first point I want to make is that the cloud offers tremendous opportunities to improve the efficiency, agility, and scalability of existing enterprise software. I made this point 0 because this is really the basis of my entire presentation. I'm not going to spend a lot of time on this because I'm going to assume that most people attending an aws-reinvent conference already buy off on this somewhat. Andy Jassy actually spent quite a bit of time in his keynote yesterday talking about how the cloud can provide lots of opportunities to increase the agility of enterprise software. The short version of this is really derived from well-known qualities in the cloud, like metered usage, capacity on demand, global reach, and ready-made application services. The next point I'd like to make is that businesses want to leverage and extend their existing investments. This is a pretty obvious point, and it applies equally to physical product lines or technology investments. When businesses have something that's working well for them, they want to extend its life, extract more value from it, and make it perform better. In other words, they generally don't want to start over. So that point leads pretty much directly to this one, which is really that we've seen this before. New computing technologies almost always augment rather than replace existing technologies. We've seen a number of examples of this over the years, and I'm going to walk through 2 of them right now. So my first example of a technology advancement is the introduction of workstations and client-server architectures. My personal first job out of school in the early 90s was working for Ameritech, which was a regional Bell operating company, and we were building a client-server front end to their existing billing system. We were creating a graphical client on Windows for Workgroups that was making RPC calls to a server that was doing screen scraping from a mainframe running CICS. And I think it sounds all a bit silly now, but at the time it was actually pretty hot stuff. And I was fortunate enough to be working on the RPC portion of it rather than the very gnarly, nasty CSCS screen scraping portion of it. Anyway, at this point in history, the mainframe was largely predicted to be dead, But there I was working on a pretty large, well-funded project whose entire goal was to extend the value of the mainframe and integrate it with existing technology rather than replace them. So before I go on, I want to call out the interesting imagery that you find if you search for client-server networks these days. I particularly like the beige tower server there and the sophisticated hub at the center of our client-server network. I was pretty shocked when I searched for client-server and found that it looks dated now. So, I wouldn't want to start a mainframe business these days, but 30 years after the introduction of client-server and workstations as the replacement for mainframes, they're still big business. This is 2013 data. If you're a bank, a retailer, or a big company, chances are you still have mainframes behind the scenes somewhere. And this is still IBM's most profitable business line. So this is a quote I took some liberties with from an IBM white paper about mainframes. And they make the point that web browsers are really just the latest user interface for mainframes. And if you're dealing with a bank or a retailer or a large business, this is still often true. So the next historic change in technology that I want to take a look at is service-oriented architectures. SOA is a design pattern that's intended to simplify the creation, deployment, and management of complex applications. The focus of SOA is on creating discrete services that interact with each other through loosely coupled interfaces. SOA has taken a lot of flack over the years, but there's pretty broad agreement that it's a valuable, the core tenets of SOA are valuable and are applicable. But did enterprises go rewrite all their software to embrace every aspect of SOA? No, they really didn't. What most businesses did is they cherry-picked bits and pieces from the ideas present in SOA and applied those to their existing applications. And they created what I'm calling SSOA, which stands for sort of service-oriented architectures. So you see a lot of this today. Okay, so historic advancements in technology was the last point. This point, my final point, is that production software often needs to be explicitly designed to run well in the cloud. This is because the performance, durability, availability, and atomicity characteristics of the cloud often differ slightly from what you're going to find on-premise. You must think about things like eventual consistency and the CAP theorem when you're writing to the cloud more than you need to think about those concepts when you're running an application in your own infrastructure. All of that really makes it difficult to do forklift upgrades of entire complex enterprise applications to the cloud in one fell swoop. Okay, so that was 4 points that are trying to highlight that I believe that enterprise adoption of the cloud will occur, but it will also occur gradually. So let's change gears a bit. And I'm going to play the director of application development for this fabulous looking application here. So based on its complexity, I'm going to say I probably work for the Health and Human Services Organization, and this is the Obamacare website. I'm sure there's 500 million lines of code in here somewhere. Anyway, so this application has some barriers that are blocking cloud adoption, but also some opportunities. So I'm going to go over a few of those specifics. So this piece is running on a mainframe. Comes up again. It's too costly for me to rewrite this and start from scratch, so I really don't want to mess with it. This is my data warehouse that I use for doing business intelligence. The problem with this component right now is that it's underperforming, and it's going to be pretty difficult for me to scale up to meet my needs. I'm also paying quite a bit in licensing fees for the data warehouse software. This component over here is housing sensitive medical data, and it has heightened security and compliance needs. And so while it could be written to the cloud, there are some additional barriers there that it's going to make it more difficult for me to migrate that service and its data out of my four walls. So over here, I have my web tier. This is already written to be a scale-out ASP.NET application, which is good, but I'd like to be able to take advantage of auto-scaling to handle bursty load that's hitting my application. Right now, in my own data center, when I have sudden surges in demand, it's difficult for me to meet that. Even though my application was designed that way, it's hard for me to get resources for my app to take advantage of that. And finally, I have my internal development and test lab that's facing some challenges. So during the day, there's a lot of contention for this single environment. People aren't able to run their tests because the system's always busy, while at night, it's pretty much underutilized. And because it's a single environment, my teams can never run tests in parallel. the environment's often polluted and down due to old builds and bad data that's on the system. So overall, this lab has really become a bottleneck in my entire software development lifecycle. So the rest of my application is actually fine. The hardware's paid for, I don't have a lot of bugs or need to add a lot of features, so in general, I don't really want to mess with it. Okay, so given the challenges and opportunities in this application, and the 4 points I raised earlier, what are my options for starting to adopt the cloud? Option number 1, punt. So this works in the short term, and there are some businesses that are still following this approach. But eventually, disregarding the advantages that you can get from the cloud is going to benefit your competition. Said another way, you might come down on the wrong side of natural selection. Or I should say your app might, not you personally, but your app might come down on the wrong side of natural selection. So the second option is creating so-called private cloud. Again, as Andy Jassy mentioned yesterday, this often amounts to not much more than on-premise virtualization. And while on-premise virtualization does provide a lot of value, those benefits don't overlap with the benefits that you get in the cloud generally. On-premise solutions have higher CapEx, they have lower elasticity, they usually lack the scalable application building blocks that you can find in the cloud. And most importantly, your IT shop still has to manage the on-premise virtualized infrastructure as well as the applications that are running on top of it. So you've lost out on an opportunity to make the infrastructure, the application components, someone else's problem. The third option is to start creating hybrid applications. This is really what I'm here to talk about. So I described this earlier briefly. I provided a more complete definition here, but basically the idea is that you have an application that's running in multiple places, often partially on-premise and partially in the cloud. The important part is that it's the application that you're focused on changing rather than the infrastructure that it's running on. Well, isn't that just a hybrid cloud? Well, as most people define them, hybrid clouds are some sophisticated integration of on-premise infrastructure with cloud infrastructure. And again, a key point of hybrid applications is that you don't really need to change your own infrastructure. With a hybrid app, you keep doing what you're already doing on-premise, and you start taking advantage of cloud resources and cloud applications opportunistically. So the important point here is that a hybrid app doesn't preclude a hybrid cloud, but it doesn't require one or depend on one either. So let's return to my role as the owner of this gnarly application. So I've found 3 components that I talked about earlier that I can uplift and take to the cloud. So if you recall, this is my data warehouse, and it wasn't meeting my scaling needs, and it was going to be difficult for me to scale up. So let's port that to Amazon Redshift. So this will definitely take development effort. Migrating your data warehouse to Amazon Redshift won't come for free, certainly, but I can expect dividends in terms of reduced cost, better scalability, and ultimately better insight from my data. So the costs for me to do this are worthwhile. The service overall was fairly easy for me to migrate because it was self-contained and it was not latency sensitive to the rest of my system. So next, let's take a look at my web tier. As I mentioned, this is a scale-out ASP.NET application, but I want to take advantage of auto-scaling to handle bursty demand. One challenge with this layer of my application is that it has a database, and its connection to its own database is very latency sensitive. So that makes a very poor spot to split my application. So instead of dividing my application there, what I'm going to do is I'm going to take the ASP.NET service and its database and move those out to EC2 and RDS. Communication with the rest of my system is over a message bus, which is asynchronous and loosely coupled. So that makes a very good spot for me to divide my application. Okay, and finally, I'm going to look at my development and test lab. So rather than have just a single development environment, I want to be able to quickly deploy and copy multiple development environments on demand. I want each of my development environments to be fully isolated from all others, and I want them to be easily shareable. Since my night job happens to be the CTO of SkyTap, I've conveniently realized that I can get all these qualities and more by moving my development and test labs into SkyTap. I'll demo a few of these capabilities in a few minutes. Since SkyTap is running, as of this conference, both on SkyTap's own more traditional infrastructure as well as AWS infrastructure as a back end, I'm able to keep my development labs and my production environments running on the same type of infrastructure so that I have less differences between those environments and less chance for unexpected problems. So those are really the only components that I want to move. At this point, I've created what I'm calling a hybrid application. It's partially on-premise and it's partially in the cloud. One key is that the services that were problematic for me here, my mainframe and my high compliance data, didn't have to move. I didn't touch them. I just left them alone. In fact, most of my application is left unchanged. I've just moved the parts that were very advantageous and easier for me to move. So I'm sure you've heard the saying about how to eat an elephant. Anybody have the answer? Yeah, there you go. One bite at a time. So it's the same idea with migrating enterprise applications. You bite off one service or one component at a time, opportunistically, and move those out to the cloud. So to do this, you need to start looking for candidates to move to the cloud. So here are a few ideas for going about finding candidates to migrate. The first one is that services that you already have, that you're already running, that aren't meeting scalability needs. Rather than try to figure out how to do this on-premise, it makes sense to think about moving these things to the cloud because the cloud generally provides better elasticity and scalability than you're going to be able to achieve in your own infrastructure. Another common candidate for migrating to the cloud are services that you can achieve quick payback on by reduced costs. This comes from cloud characteristics like metered usage, low hourly rates, and the ability to scale down your application as well as scale up your application. There are often also new opportunities in the cloud. I used the example earlier of auto-scaling for my web application. This is something that I needed to do in my application and I didn't have available on-premise. The cloud provides ready-made components, ready-made application services that I can take advantage of quickly in my application to improve it. So the next candidate are services that can benefit from global reach and reduce latency to end users. This comes from the fact that most cloud providers like AWS have very broad geographic distribution that's generally going to be better than what most enterprises have in their own infrastructure. So by taking advantage of global distribution, you can get closer to your end users, achieve disaster recovery and failover, things that are difficult to achieve when you're building out your own infrastructure. And the last point up here are non-production workloads like development and test labs. This point is relevant because non-production workloads associated with your application often have fewer constraints and are easier and faster for businesses to move to the cloud. This is also something that Andy Jassy talked about yesterday in his keynote, and he mentioned that migrating dev test workloads is often one of the first and key strategies for businesses to start adopting the cloud. So once you've found a candidate for migration to the cloud, what are some of the qualities that are going to make it either easy or difficult to move that component out to the cloud? This isn't a completely exhaustive list, but these are some of the highlights to look for. If you have one or more of these characteristics in your application, it's generally going to be easier for you to move. So the first one is, I think, pretty obvious. It needs to align with your corporate security and compliance policies. If you're being opportunistic, there's no reason to try to swim upstream here. So the next point is if it's services or components that are loosely coupled to other services. Like I was talking about earlier with that complex enterprise application, if you can find dividing lines where there's not tight coupling between your services, that's usually going to make a good boundary to cleave off parts of your application. Not sensitive to latency with other remote services is closely related to that. Because you're going to be splitting your application across further distances and increasing latency, if those components are sensitive to latency, it could cause problems. Related to that is our idempotent protocols within your service. So once you start splitting your application into multiple locations, the chances for hiccups and disconnects and problems with networking starts to go up. Idempotent protocols are a mechanism for applications and services to be able to essentially retry operations without having to worry about negative side effects from retrying. So it can greatly improve the reliability of your application. And then the last point are services that are already scale out and fault tolerant. These applications generally are designed in such a way that's pretty compatible with the way cloud infrastructure works. Okay, so it's never quite as easy as I'm making it all sound. What are some of the key challenges that you're going to face when you start migrating components to the cloud? The first one is that you're probably going to need some type of federated authentication and authorization technique. You previously were doing this on-premise. When you move things to the cloud, you may be dealing with new APIs and new services, and you're going to need to find a mechanism to achieve authentication and authorization over those new services. The next is new deployment strategies. Deploying bits in the cloud and deploying bits on-premise may or may not be the same. Often, it's not the same. Different monitoring and alerting strategies are going to apply. In the cloud, you're generally going to need to use the cloud providers' services for achieving alerting and monitoring. On-premise, you have generally a broader array of tools to pick from. So whenever you're splitting an application, you're going to face data placement concerns. You want data to be located close to the services that are consuming that data. So as you start splitting things apart in your application, you're going to likely face the need for doing data replication or caching that you didn't previously have to deal with in your application. And the final one up there is a need for new IPC mechanisms. If the way your application communicates is very latency sensitive and very tightly coupled, you may want to think about things like message buses that are going to make it easier to split your application. This helps you achieve qualities like guaranteed delivery and idempotency that will make it easier to split your application up. Okay, so to summarize the slides, I strongly believe that enterprise software is going to evolve to the cloud. Cloud adoption within the enterprise should focus on the creation of hybrid applications rather than hybrid infrastructure. Complete forklift upgrades to the cloud really aren't desirable, shouldn't be expected, and aren't very practical. So this still isn't easy, but the tools are improving, and there are purpose-built services like SkyTap emerging on the scenes to help you move specific workloads out to the cloud. So I thought I'd end with some evolution humor. I kind of like this one. All right, so the next thing I'm going to do is show you a bit about SkyTap and how it can help make development and test teams more efficient. So let's see, I'm going to switch over. Okay. All right, so, that's not, a second. There we go. So SkyTap was purpose-built to give developers and testers a self-service tool for the simple creation, copying, and sharing of complete development environments. The goal is to remove the bottlenecks and problems that people face in their software development life cycles to help teams move faster. So this is the dashboard of SkyTap. Here I can quickly get a view of, or quick access to basic documentation. I can see my recent activity within the product and get an overview of my own usage. SkyTap supports usage limits and quotas applied to individual users. So this area gives me a sense of how close I am to hitting those limits within my account. The next thing I want to describe are templates and configurations. Templates are read-only snapshots of entire development environments. They're more than just definitions of those environments because they include all of the VM state that's associated with them when you create the snapshot. So in this case, that implies the disk state, memory state of the VMs. Configurations are installed runnable instances of development environments. So I'm going to look at my list of templates. These are a bunch of templates that have been provided to me or created for me by other people in my company and shared with me through projects. Projects are SkyTap's mechanism for sharing resources. So I'm going to look at all the projects that are accessible to me, and the one that I want to work with is a project called Applications Under Test. This has been created by someone else in the company and shared with me, so I can filter it down to the list of templates that are in that project. I can further filter this down to a list of templates by region. SkyTap supports a number of different regions, our own infrastructure regions now, as well as of this conference, Amazon regions. So I'm going to select the Amazon region. And this is the template that I want to work with. This is a web application that's built on top of WebSphere. So I'm going to install that and create a configuration from it. So what this does is it forks off a new independent copy of that template. So I now have my own copy of this environment that I can start working with and manipulating. Initially, this is an exact duplicate of that template. So it includes all of the same networks, the same VMs, the same network addresses, the same disk state as that template. But it's an independent copy, so I can start making changes to this on my own without affecting anyone else. So there's a couple important qualities here for development and test. The first one is that because I'm starting from a known good, clean state, I started from that template, I've got a clean environment to run tests. A common problem with physical test environments is that they're polluted by other people's changes and failed builds over time. By starting from a clean state, I always know where I am in my testing cycle. So another important difference from physical environments is that this configuration is fully isolated from all others. So I can safely run my tests here without worrying about impacting anyone else in my team or my company, because this environment is completely separate from all others. So behind the scenes, this actually represents an Amazon VPC. So all the networking traffic is fully isolated from all the other environments in SkyTap. Now I'd like to start making adjustments to this environment. So the first thing I'm going to do is add a few more VMs. And to do this, I'm going to go find that same template that I just installed. And instead of installing the whole thing, I'm just going to pick a few instances of WebSphere and add those to my configuration. So now I've just added 2 more WebSphere instances to my configuration. I can go rename those. And one of the things to note here is that by default, SkyTap preserves all the IP addresses from the templates that you're installing, but because we detected conflicts here by bringing in duplicates of the exact same machines, we've found addresses in the correct subnet that these machines are attached to and given them different addresses that don't overlap automatically. So now I want to start editing my network topology a bit. Right now I've got everything jumbled together in a single network. All the VMs are connected to this one network. And so I'm going to create a new network with the intent of putting externally facing components on this network. So I'm going to call it a DMZ. And once that's created, I'm going to move my load balancer machine from my internal network to my external DMZ network. So now you can see I've pretty easily and quickly created 2 subnets within this configuration, which behind the scenes represents a VPC, and moved a bunch of machines between them. So if I go back to my configuration here, I've now built out an environment that I'm happy with. I want to be able to return to this in the future. So I'm going to save this as a template. And again, what this does is it saves a point-in-time read-only copy of this environment with all of its state. So I'm going to call this Plants by WebSphere V2. I can select a subnet of virtual machines or networks if I wanted to, a subset, and save that off. And once this is created, I'll now have a new read-only copy of this environment. And so I can use this for myself as a point to return to, or I can add it to a project. And like I mentioned earlier, projects are our mechanism for sharing. So I can make this environment that I've just taken time to build out available to other people in my business who can then start stamping out their own copies of this development environment to do their own work. So what I'll do for now is create a second instance of this configuration for myself. So once this is installed, you'll see again that this is a duplicate of the environment that I just created. If I return to my list of configurations, you can see that I now have 2. I have the original one that I was modifying and the one that's based on the template I just installed called V2. And again, these are completely isolated, independent environments with a different VPC backing each of them. So I can run tests in parallel here without worrying about polluting my own environments. I can do A/B testing. And of course, it doesn't just apply to me. It applies to everyone in the business who wants to use this template. So I'm going to run these things. But before I do, I want to flip over quickly to the EC2 console just to give you a sense of what's happening behind the scenes. Normally, as a SkyTap customer, you wouldn't need to do this. So this is the Amazon account that's backing this SkyTap account. And you can see I have a number of instances out there right now. So I'm going to come back here and pick these 2 environments and deploy them. So what SkyTap's doing now is it's actually creating the VPC, all the subnets, the routing rules, internet gateways, network ACLs, EC2 instances that are needed to create this environment. There's a whole lot of things going on behind the scenes to deploy these components on Amazon. So if I flip back over to the EC2 console and refresh this, I can see that instances are starting to appear. There was one there. So the list is growing. So all this stuff is being deployed now within Amazon. So if I jump back over to SkyTap, as these things turn green, that means they're running and they're ready for me to start interacting with. So now is when I can log into these machines via SSH or RDP, however I want to connect to them, and start doing my development work or my tests that I want to run. So I'll return to the list of configurations and show you the other half of this. Well, let's wait for this one to finish spinning up. There it goes. So they're both running now. So I'll show you the counter to all this, which if you've ever deployed environments in Amazon and VPC, you realize that not only is building out environments challenging, but tearing them down is pretty challenging as well. So that becomes much easier in SkyTap. I hit the delete button, and I say, yes, that's really what I want to do, and bang, they're gone. So now SkyTap is doing the reverse and tearing down all of those resources that we deployed in EC2. So if I switch back to the console again, I can refresh it, and I'll see that the number of running instances has dropped down to what it was before I started running. The reason these are here, by the way, is that other people within this account are running instances as well. Okay, so giving developers self-service access to a tool like this really can help them move faster and innovate faster. But if this was left unmanaged, it can lead to sort of unexpected costs as people consume lots of resources. So to solve this, SkyTap provides a pretty rich set of administrative tools that help account owners understand and control what's going on within their own accounts. This helps them manage costs and ensure that people are complying with corporate policies. So I'm just going to skim through some of this quickly, but this is a list of users. So any user in my account, I can dive in and see the resources that they're consuming. I can apply limits and quotas to them to prevent them from using more than I want them to use. I can add them to groups or projects. I can also control their role within the overall account, so I can make them an administrator or not. Groups are a mechanism of creating sets of users, so I don't have to deal with users one at a time. I showed you projects, and then we have a lot of reporting. One of the interesting ones is auditing. Auditing gives me a historical log of all the events that have occurred within my system. So this is particularly useful for destructive actions. So I can see here where I just deleted those two configurations. Without an audit trail, these things would essentially just disappear, and it would be hard to know who deleted your important resources and why did your development lab just go away. So we also provide basic tools for filtering and sorting the audit logs. Usage gives me a historic usage of my system so I can understand who's consuming what over time. We have a variety of security settings and policies. And the last thing I'll touch on are notifications. Notifications gives me a mechanism for subscribing to events within SkyTap so that I can receive email alerts when certain things have occurred. This is the most common use of this is to set essentially soft limits on people. So rather than give them a hard quota, you can get an alert when they've hit certain usage thresholds and deal with it that way rather than just cutting them off. All right, so there's quite a bit more to SkyTap. That's all I really have time to show you today. I would encourage you to stop by our booth at 8:20 if you want to get a deeper dive demo or talk to people about other characteristics of SkyTap. Okay, so next I'm going to invite up our panelists. So if you guys want to come on up, hopefully there's Lee, okay. So we have Ryan from DataZoo. You guys going to stand? Okay, that works. Sure, you can stand, whatever. That's fine. Okay, so we've got Ryan from DataZoo. He's a QA software engineer. We have Lee from F5. He's a lead engineer, and we have Paul from Fulcrum, who's the director of IT. So I'm just going to ask these guys a few questions about how they've adopted the cloud within their enterprise, their applications. So hopefully this thing's working. All right, excellent. So I guess we'll start with you, Lee. So the first question is, tell us a little bit about your organization and how you guys are using the cloud for your applications.
All right, so my name is Lee Orrick. I'm a new product introduction engineer. Can you hear me out there or not? No.
Maybe put it.
All right, now? I'll just talk loud. My name is Lee Orrick. I'm a new product introduction engineer at F5 Networks. My group, or the group I work for, is responsible for doing update training. When we put out a new release of the big IP software, we need to train our internal people on how to use the software and the new features that they're going to be supporting for customers. It turns out that a lot of times the field sales engineers and our consulting group, there it goes, also take that training. So in prior releases, what we've done in the past is we've shipped gear out to the different locations, EMEA, APAC, to the different regions. We'd fly one of us out there. We would go do stand-up training for a week, fly all the people to that location, and we'd have a rack of gear there that we would use to conduct the training for the labs that we had that were in conjunction with the training itself. The decision was made that we were going to go to an all-online training process. So all of our training was going to be web-based training modules. The thing that we were missing when we went to that was we had no way to provide that hands-on lab experience that we gave to students when we flew on site with them. So we started looking around and we found, we wound up choosing SkyTap. And what we do is we build out the full virtual environment for our students for each lab. We save those off as templates. And then when the student is done with their web-based training, with a single click, they do a single click on the back end, the API pulls up that template for them, gives them a fully configured lab that they can then go in. The labs are fully licensed, everything's up and ready to run. They go in, they do their lab exercises, and they get that hands-on experience.
Great. And so I assume another important characteristic is when they're done.
Right. And so what we have is we also have it scheduled so that 4 hours after they're done, or 4 hours after they instantiate the lab, it automatically deletes. It's on a schedule within SkyTap that it deletes. So I don't have to worry about cleanup. I don't have to worry about any of that stuff. I don't have to worry about giving them the lab. It's all automated.
Thanks. So one of the interesting things that SkyTap has noticed over time is that although we're focused on development and test, virtual training actually has a lot of similarities to development and test in that you need to stamp out multiple copies of a similar environment over and over again, and you want to be able to create and destroy these things really rapidly. Okay, so Ryan?
Hi, I'm Ryan Carey from DataZoo. DataZoo is a tech company in the marketing space. We put ads online and through video and mobile for our clients. The unique feature of our platform is we use machine learning as campaigns are running to learn which groups of people are interested in the ads and then refocusing those ads to those groups so we can get better lift, better click-through rates and actions on those campaigns. So at DataZoo, we've started moving into the cloud, and we started with Dev and Test and SkyTap. Previously, we had limited resources that we needed to share, and SkyTab provides us the ability to start up instances as needed, and we can run multiple test environments now, whereas previously we were limited to a single shared instance for all of our developers.
Okay, great. And Ryan's being a little modest. They actually there was just an announcement that DataZoo was recognized as the 5th fastest growing company in what, United States, I think?
Yes, in the US, the 5th largest, fastest growing private company, and #1 in the marketing sector. It
was something like 2,000% revenue growth or something like that, right? I mean, it's good. Yeah. Okay, all right. So Paul?
Hi, my name is Paul Howery. I'm the IT director at Fulcrum. And we make the software that keeps track of probably 75% of your cell phone carriers. It's this giant enterprise, humongous thing that integrates with all sorts of stuff. But we got to develop to it, we have to train to it, and everything else. And it led to us getting into the cloud about 2 years ago on a training thing, not dissimilar to what Lee was talking about. And we had to train the whole workforce of the largest wireless carrier for their maintenance and build-outs and so on. So what we did, we spun up environments that were test mocks of their systems, of their actual enterprise systems. Spun them up in a day, tore them down, saved them for 3 days in case there was something they needed to follow up on. This went over for 7 weeks straight without a single issue. It was pretty awesome. And at that point it was like, wow, if we can do this, why don't we do this in-house? We were doing the same thing as Ryan there. We'd have an environment, multiple people would be hitting it, testing would go along, then we'd have UAT hit it, but they'd made a change in testing because they figured out something was wrong, but it didn't get into the UAT list, so on and so forth. Then we figured out, wow, we can copy 1 million of these things, and they're identical. we were ecstatic about that because instead of our developers and our testers and our QA sets tripping on each other, it didn't happen anymore. So we found that to be a real successful element. And then relative to what the Brad's talk was about, our enterprise product is actually sitting behind a firewall. We have a subsection of that product we just moved into AWS. So it's his model that he's actually talking about. And that runs and talks to the behind the firewall system. And then we're now developing our third product, which is full on greenfield to it. It's designed and built in the cloud, and it's actually deployed specifically for enterprise asset management in using the cloud-based elements. So that's pretty much what we do.
All right, great, thanks. All right, so the next thing I'd like to talk about is what considerations and benefits did you have from adopting the cloud?
Okay, well, we had a couple of requirements. We went through a full requirements gathering and came up with a matrix. We evaluated using our internal ESX systems, building something entirely new, expanding what we had, or going with an outsourced provider. And the main things we wanted to have were we wanted internet access. The environments needed to be internet accessible directly. So I didn't want to have users VPN in to get access to these resources. We're a worldwide, we'll say global. We're a global company. We have support centers in Japan, in Singapore, in the UK, in the US. All of these people, we have consultants and FSEs that are on the road. All of these people, I wanted them to be able to get to this environment with the fewest steps and strings possible. So internet access, direct internet access was one of our things. And then I didn't want the admin headache of setup and tear down. I needed to be able to have multiple people taking multiple labs, have the environments fenced off so that they don't conflict with each other, and when they're done, they can go away. And since I can use the same IP, I wanted to reuse the same IP address space because then I could templatize all of my training documents, all of my training diagrams. I didn't have to redo them every time. I could just reuse what I had for every lab that I do. And then the final thing that we needed was, hold on. We needed something else. Oh, I wanted it to be highly available. That's kind of what we do. It's what I think about on a daily basis. SkyTap had multiple data centers. So we had their West Coast and their East Coast data center. So I wanted it to be in multiple places. I wanted to get the content as close to users as possible to improve their user experience. So when they started talking about taking their interface and putting it on top of AWS, my gears started turning, and I could see the multiple other regions that I now had access to that I could push this out to and get it closer to my users, our user.
All right, excellent, thanks. Yeah, it's interesting to know we see the need for not only internet access from a lot of our customers, but specifically web port 80 access. So a lot of SkyTap can be actually tunneled through port 80 so that if you're in a hotel or a convention center or casino that's blocking a lot of ports, you can still get access to SkyTap. Okay.
All right. So from a tech perspective, the features that DataZoo wanted in the cloud for our dev test environments were first, the ability to create multiple VM private networks for testing so that we can have multiple components in a test environment isolated from everything else, where we can run more complex testing rather than the simple unit testing that we do on single machines. Another feature that we needed was the ability to do snapshot and then share the state of those configurations. So if there's a problem in QA, it can be then just pushed off and handed to back to the dev team.
Great. Yeah, that's a very common use of SkyTap, is the ability to clone an environment that actually has a bug currently being replicated in it, or reproduced, so that you can snapshot that and hand it off to someone else to take a look. So do you guys build environments that are that match what you do in production? So your environments in SkyTap look similar, have a similar topology, similar infrastructure?
They do, but again, scaled down.
Sure. Yeah.
But the new feature that we can do now, whereas we had one system, we can now test with multiple components of our system individually. One developer can put the whole stack in SkyTap, scaled down quite a bit, but
right, absolutely. All right, great, thanks.
Right.
Paul?
This is almost a where do I start with how many different things we had to think about. The first part was the training element, and just is the availability there, and it was, which really helped us out immensely. our option was to have that in-house and expect that we were going to be able to handle 3,500 people training off our systems. So we were able to accomplish that using the SkyTap. That was one of the things we had to measure on. Internally, we wanted to find out if we could actually replicate and set up our clients' environments in SkyTap and replicate those. What they developed was a really cool option, which was natting. So we'll have basically 9 environments of 3 different sets of iterations for our clients, and they'll all be running, and they're exactly identical to every single bit inside of them. And they can all run the tests without stepping on each other. You don't have a dev group, trying to develop one thing which may break the system, which stops another person in the dev from doing another area. So we just split it up that way, and it creates for a lot less stub in your toe. That really was an amazing help to us. The newest thing, which I'm really happy about, is we have stuff that we put, because the opportunity was there to put it in the cloud, take part of our product and set it into AWS. Now we'll be able to take that, keep it in our same development paths and environments that people are used to and comfortable, which should keep our efficiency at a higher level. So we're looking forward to getting that stuff fully implemented, and those were our main considerations, I think.
Yeah, great. So there was an interesting point there, I think, which is that a lot of people are trying to replicate their own production environments in SkyTap or in the cloud. It sounds like you are creating somewhat custom software for your customers, or at least custom installations, and so you're trying to replicate customer environments within SkyTap. Is that accurate? Yeah. Okay. All right, so the last question is any words of wisdom for people that are trying to move their own workloads or components out to the cloud?
Okay, so I have a couple things on this. Probably the biggest challenge we had, we're doing this all virtual edition. We're not doing any of our hardware. We sell a whole line of hardware. And we're doing this dynamic generation of these environments, and licensing for these became quite a big stumbling block in all of this. Not everybody's figured out licensing and how to let you license something and reuse that license multiple times, and how are you going to get charged on that. So we were creative in how we figured out our licensing strategy. And the other big kind of non-technical stumbling block was going through our legal department and our security group and getting sign-off from them to say that, yes, you can do this, you can use this service to provide your training. So we went through some iterations with them to get it all figured out and signed off on.
Excellent.
Actually, there's the one other thing was we had an internal initiative that we were about 3/4, almost all the way done with it, and we were told, well, what if we had a private cloud internally? And luckily I had my matrix of things, my requirements that I wanted, and I said, you won't give me direct internet access to these instances, and they wouldn't. So the distraction of someone trying to sell me a private cloud when we'd gone down this path, they were late into the game, and it was just a last minute thing that I had to deal with.
So we do see that fairly common when SkyTap is selling to businesses. We're often being compared to what on-premise infrastructure can do and look like. And so it's a pretty common decision that enterprises and businesses are making, is what are you going to get on-premise and what are you going to get in the cloud? And
the automation, the automatic tear down, build up, that whole thing, we started looking at what was it going to cost to do that. We were going to have an FTE to maintain all of this equipment, this infrastructure. I didn't want to be involved in the maintenance of it. I wanted to be a user, a power user, but I wanted to leave all the maintenance and operation stuff. I wanted to call him.
He has occasionally.
All right, so moving from dedicated servers to VMs inside of SkyTap for dev and test, one of the things that we decided to do was to automate all of our DevOps operations. So we chose a tool called Ansible, and we run through all of our setup tools using just script files to create the SkyTab templates for our dev environments. And we've seen a lot of unintended benefits from this approach. One is that some of our developers then took these playbooks, and deployed to their own personal computers using vagrants for when they're away from the office. It really worked out well using an automation tool like this. We also now manage all of our machine configurations through Git repo, so we can manage all of the changes in the system that way.
Yeah, so Ansible is similar to Puppet and Chef, correct? Yeah, it's used for putting down bits usually within the operating system, so operating system bits or application bits. One of the things that we've started collaborating with these guys on is the idea of helping, letting Ansible be able to drive SkyTap so that you can provision not only the bits on VMs, but the infrastructure through Ansible. So that's actually been kind of an interesting project for us.
Yep.
This is the what would you consider?
Yeah, words of wisdom.
Oh, words of wisdom.
Yeah.
Oh. Go with this. If you can put the data there and it's appropriate, do it. Just because it's going to put you ahead of the game as various groups move forward. Other companies are doing it. So, I mean, we're developing a product that's primarily cloud developed and cloud based, specifically knowing that in the future it's going to make that easier for a customer to adopt that product. That was our whole goal in doing that. And heck, we're in the process, it's working, and it's great. The second thing is do it in increments that work, because I have to work with my executive team, and in process that I have to explain certain elements. Do things in a small chunk, kind of phase it in so that it's comfortable for them. Because if it's comfortable and you do it at points where you succeed, they feel better. The biggest impetus is not because the technology is difficult. The technology is there, and it's just like any technology that you work with in-house even. But they need to see it and be comfortable with it. And if that's the case, then they get happy and they look at it differently. They look at it as a tool to make things easier and faster for your own operations and development. At least that's how I approach it. And I will tell you, it has worked very well in communicating with my teams for that.
Great. Okay. Thanks a lot. Yeah, I think that's actually an excellent point. Early cloud adoption is a chance to be opportunistic and pick off the easy wins, essentially. And I think that's a very smart place to start. Okay. I appreciate it, guys. Thanks a lot for coming up. All right. That's actually... Whoa, put it down there. So that's really the end of the session. If you guys have additional questions or you want additional information from the customers that were up here or myself, I'll hang out here at the end of the talk for a few minutes. Or please stop by our booth at 8:20 and you can get an additional demo and talk to people at SkyTap to get more information. All right, thanks a lot.